Welcome back to chapter number 2 about the Houdini particle effects introduction. We talked about a brief introduction to particle system, and we saw just something about the shelf creation, about the pop network. Something that is really useful is to understand how it works with a particle emission. So the idea is to continue working on the scene and then moving up to creating something more complex. So talking about particle emission, we have different ways. So let's create a new geometry. We can create directly using the grid. Grid is a basic geometry, so let's say grid emission. Okay, and you see that there we have a grid. Let's say G emitter, and we go to scale this one down, so it will be 5 meters by 5 meters, maybe less, 3 meters by 3 meters, and we have just 10 rows and columns for the moment. Let's use a transformer node to move it. This one can be called fix position, and let's set to available over the z-axis. We can go, maybe we can directly use the right position there. The x-axis is this one, so let's go in this way, and let's say that this one is set to maybe 2 meters, maybe a little bit more, so 4 meters. Okay, that's our basic scene, and later we can see how it works creating something there. So we have different ways to create a mission. Playing inside the scene, actually it's inside this dop, and the dop is connected to the source with the sphere, and actually it's using a different way to create the particles, but the idea can be something like that. Let's go inside the basic emitter, and let's see how we can create something directly inside the emitter to create a pop network. And it can be done without any problem. So let's say that we have a pop network, and you see it's the dot network at the SOP level. So we are working inside the surface operator. Let's connect to the first one, and you see that we have particles. So let's say that we have particle system. Going inside, you see that we have everything again set for us in a really simple way. The difference between this setup and the previous one is that if we go inside the source object, you see that there we have the emission type set to scatter onto surface, and the geometry source is the use first context geometry. The first context geometry is the first connection, this one, okay? In the previous version we had there the source set to scatter onto surface as before, but we have a use parameter value and we have the connection with the SOP. Okay, so let's go back there. The features are the same, so we are working on the same way as before. So you see that that's a way to scatter stuff and particles inside the scene. So you see that it's working essentially as we done before. Let's imagine that we like to emit particles just from one area of this mesh. You can imagine, for example, to create a group. Okay, let's say emission group, and there, let's go to select the group. We can do maybe with a bounding. So let's say that this one is 3 meters. You see we are connecting, selecting some faces. So let's say that that's the group, and we call it emitter. Okay, then you have two possibilities. I have to say we have many possibilities inside Houdini. By the way, we can do something really simple. We can imagine, for example, to have a blast. So with a blast, let's call it eraser. This one is going to remove the emitter, and we say delete, not selected. Okay, so in this case that's the emitter, and we can think about to have a merge, and then we have this one and the particles. So in this case you see that we have, obviously the connection needs to be done with the first one, and we can remove with a Y key this one. So we have the creation. You see there we have the emitter. Let's just to give a better way to read the graph. We are removing some parts. We are then using the particles there, and then you see that we have the particles flying away from this point. Okay? If you saw something strange about the particles, you see that we have particles flying away. It's just because we are seeing the particles out of there, so you can say, okay, let's hide other objects, and in this way we see just the particles from the scene. And that's done. That's a really simple way to emit particles just from one area about the our scene. Let's move to the next step. Okay, so this one is a really simple way to emit stuff. Let's imagine that we like to emit stuff in a bit different way. So let's use this one. And then we say use a scatter. Scatter is able to scatter points over the surface. So you see that now we are scattering 1000 points, and we have the possibility to control, you see, the position without with the possibility to have more cows or less cows and stuff like that. By the way, it's not a problem. Then if we have, let's say, Ctrl+C, Ctrl+V, we have a new pop network. Okay, if we go there, this one is not working maybe as we know, because there is a problem. We have no more object there. Let's call it scatter points. If we go there, now we need something else. You see that inside the source, the guide is the blue points. So we have to say how it can emit from the points. You see that there we have emission type, and we have, for example, all points, or you have points. And something to, let's say that we have a pop, maybe a pop force. It is something we go to see later. Okay, let's say that we have this one. Okay, you see that we have the right emission. Let's remove the guide. So you see that the particles are emitted from this point. Okay, if we go to all points, it's using all the points to emit particles. So it's a little bit different. You see that every single point, it's continuing emitting particles. In the other way, it's using the number of points to be emitted over time. So the effects is a little bit different than before. Okay, let's think about another way to do stuff like that. So if we go back, you know that we have there the scatter points, and this one, let's say that we have again the possibility to generate 500 particles, and you know that the particles are just over the surface. Inside we have no particles. So if we like to, you know, there obviously we have the possibility to create some different ways. For example, you can imagine to do something like that. You have the group, and then with the scatter you can say let's use the meter, and you know that the particles are emitted just over this group. So that's another way you can use to emit particles. By the way, the idea is to use a volume to to generate particles. So let's say that we like to have a VDB from polygons. Okay, that's our sphere. Let's say that we go from surface with a distance VDB to fog. So we have the density. Now we can connect to this one, and then we have to remove obviously the group. And you see that now we have the points, 500 points, also inside. Okay, so we go to have something more precise. So let's see the VDB. Let's go for a voxel with an higher scale. You know, the voxel is the voxel space. Maybe we can do an image to explain better how it works. So let's do some basic idea about the volume and the voxel. You know, we have inside the scene a sphere. Okay, that's our mesh, and we converted to a VDB fog. So we have the density, and the density will be used to add the particles. By the way, to transform the sphere, the geometry in a VDB, we have to move to the voxel space. The voxel space is, let's imagine how it works. We have the bounding box for the sphere. Okay, so that's the 3D bounding box. Don't take care about the, it is not so nice. By the way, that's the bounding box. Okay, so that's the B box about the sphere. So the sphere is inside this volume, and in this way we know when we have the density high. Let's imagine that there we have 1.0 about the density, and in the empty space we have 0.0, so we have no density. In this way we know how we have hacked to understand where the particles can be applied. The resolution for the conversion between this one, so the 3D mesh, and the volume is using the voxel space. The voxel space, it means that this box is divided in cells. Okay, so let's imagine that this one is split in cell. It is something that is similar to the pixel. You know, the pixel is essentially a rectangle, you know, but it is a code because we have both sides in the same dimension. The voxel is the same as the pixel, but it is a 3D unit. Okay, so it's a teeny box. If you set this image, you know, we can have a low amount of pixel to define an image, so it will be low quality. If we have a low number of voxel, it will be low quality. So for example, a sphere can become something like that. And that's because the proportions are not right, but I hope you can imagine. And imagine that this one is 3D. And that's just because our voxel is too big. Okay? It will need a low amount of memory, but the quality will be low. If we like to have a really precise sphere, we need a voxel with a really thin scale. So we have a huge amount of voxel, but the quality will be higher. And we are taking care about the same thing there inside Houdini. So let's go back there. And this is the voxel size. So we say that this one is 2 centimeters and a half. And you see that the quality is nice. If we say that this one is, for example, half meter, you see that it is not able to create something. It will be more clear if we go for the VDB. So you see that the quality is really poor. If we go higher, it will be less and less quality. You see that it's something similar to the schema I done before. You see that we have these boxes that are creating the volume. If we go really, really low, it will be really nice. That's 1 centimeter, okay? And that's the same for the density. So in this way, we have a really nice way to understand how the points are interacting. We have the density. Let's say that we have a huge amount of points, maybe, for example, 50,000. So it takes a little bit of time to create the points because, you know, they are a lot of points, but you see that it's working nicely. It is perfect. We have dots over the entire volume. So then there, let's go with a pop network. Maybe we can use again the same, so Ctrl C, Ctrl V, and connect. Let's go inside. That's our source. Let's remove the guide, and let's see what happened. We have to say to use all points. We have no speed, so let's press ESC, and we go to a pop force. Again, we'll talk about the forces later. Let's say the amplitude is 1, and then we go there. Let's see what happened. You see that we are moving those particles, and that's really nice. We can go to see just a pixel, so it will be a better visualization. Okay, you see that that's really nice. Okay, so we'll take care about something like that later to create some really nice effects. By the way, let's go to save the scene. This one will be chapter 2, and we are talking about the particle emission. Okay, and now let's try to imagine if we can use, for example, some colors to decide where we like to have particles. So the next step is something different. So let's say that this one is, for example, let's create a group, and this one is a blast group emission. This one is the volume emission, and C key to use a different key. Okay, let's go to work on a different setup. So this one is the second one, and now we do something. We need the CD attributes, because I like to control the density with a texture. But you see inside the geometry spreadsheet, actually we have all points inside the sphere, and we have just the P attributes. You can see the P attributes also there. You see that we have 1 point attributes, the P, and it's a 3 information float. So we have P, X, P, Y, and P, Z. So just the coordinates for each point. We have no UV, we have nothing. So we need to create something. By the way, let's go back there. And let's say that this one is split top and bottom. So there we go to have a new panel, and inside this one we go to have the geometry spreadsheet. So inspector, geometry spreadsheet. Okay, so we have the possibility to work together with the other one. So let's use you can use, for example, a material. By the way, let's go to create a point pop. So we go to play with the points. So create CD attributes. Okay, so let's move inside. You see that we have the input and we have the output. Okay, we have many stuff coming from the image, from the mesh. So we do something really simple. You see that the output, we have the CD, so the color information. We get to create a color, and to create a color we go just to use a turbulence. So let's go to use the anti-aliased noise. That's essentially just a noise. You can use this one to deform the mesh, and you can use this one to create something else. So let's imagine that we go to use, for example, the add. We can say that we use the actual position, then we use the point as position for the noise, connect the noise there, and then we go to use this one as a new position, let's go to set this one as on, and you see that we are going to create essentially a displacement. That's all. So really simple. By the way, we like to control the color, so let's remove this one. We don't need to control this point essentially because this one is the default, so we can remove this connection and connect the noise to the color. So you see that we have some kind of color. Obviously that's too simple, and you see that there now we have the PZ, PX, PY, PZ, and then we have the color description for the RGB. So each point now has a color. By the way, I like to have an higher contrast, so let's use in a really simple way a fit range. So this one is deciding to pick the source there and moving to a new destination. So let's go, for example, minus 0.25 to 0.25, and let's say that this one is the new 0, and then this one is the, or maybe let's try with this one, okay, an higher contrast, and let's say that this one is 1.5. So we are out of color, but we are sure that we have a nice contrast. The problem is the quality. Obviously the quality is linked to points, so it's something like a vertex color. In any way, it's really similar. So to have something better, we have to go there and change the frequency, or we can go there and use a subdivide, so we have no changes over this area. And with the subdivide, we are going to have an higher quality mesh. You see that we have a really nice quality now. Then back there we have the CD, and then in this case now we have the color, so we can use the color. So let's say that we have, oh sorry, this one is okay. Let's set this one to, so the idea is to use let's say a new scatter. Okay, and back to you know, we need a lot of more points, so let's say 10,000. You see that we have also the color over the points, but the problem is that we have also the black points there, and we don't need it. So it's okay to use the by density, but let's say that we go for the attributes. Density is not okay, and that's normal because we have no density there. You see, we have just P and CD. So we say, let's use color, and it is done. Obviously, to have an higher density there, we can do something. So let's say that we go there and we go back to points, so it's a little bit more clear. Inside the CD attributes there, let's say that we go for 0, 2, maybe 0. Okay, I like to have really dark range there, and we see that the, let's go really high. You know, you can take care about the color there, but if we don't like about the color, we can say, for example, later that we have a new color, and now you see that everything is white, or for example can be another color. And obviously we are changing the color there. Then if we have a pop network, we go back inside there. Let's go to remove this one. We say to use whole points, and we need let's say that we go with a gravity, or maybe just with the velocity. So let's go back there, and let's say that we have the add velocity, we say that we have 1, 1, 1. So you see that we have the particles going away all around, or maybe we can set as initial. So you see that we have, let's go to remove the variance. Okay, so you see it's flying away in this way. Okay, we can have the same using their pop force. We are using always the pop force just because it's really nice. And if we go, it's not connected. Okay, now it's connected. Okay, and you see that it's working perfectly. Let's say about the source, we go for points, so we adjust this area to emit particles, and let's say that we have a key there, so out, and then we say that, for example, at frame 25 we have still the activation, and then at frame 26 we have no more particles. So you see that the particles are flying away, and that's all. We say that a particle has 2 seconds, and we have 0.5 for the variance. And you see that particles are just flying away in this way, so that's really nice. We can have more particles, sorry, maybe still more particles, so it's really high density. And if we like, we can go there and take care about the sweep scale. Let's say 0.5. We go back and then play. Sorry. Okay. And you see that the particles are flying away with a little scale about the sphere. We can have a lower scale about the intensity. So you see that it's going away in a slower way. And then now we have a lot of points, so if we go with pixel, it will be nicer than before. Okay, that's really nice. Okay, so Control S. Let's go back to the particles. We can have something really nice. Let's go in the attributes. So let's say that we have just this part. Okay, we have the possibility to control in a really nice way also the timing. Okay, so if we like to change the timing, we can use a way to pick the position and pick also the time. But you know, we have 3 data there because we have a vector and we need to have quad data to move the position. So let's go to vector to vector 4. So we have a vector, but we have also another value, and we can pick, for example, the frame, and let's go to connect there. That's really fast. We can use the time. So you see this one is lower, just to, if we like to do something, let's say multiply, and let's use a constant. So let's say that this one is the input, this one is the output, then we go with this one. So obviously now it's working by 0, so in this way sorry, I know. Okay, so you see that now it's working as before. If we go for 0.1, obviously it will be 10 times slower about the evolution, you know. So, by the way, it's not a problem. Let's go back to the standard configuration. So that's fast enough. If we go back there, you see that we have points emission all over there. And in this case, okay, we have the color. Then let's go in the pop network. And obviously we'll have particles. Let's try to do something faster. So let's say that we have maybe 10 times less particles. And then you see that we have this kind of particles that are flying away in a really, really nice way. That's really powerful. Okay, so it's a nice way to have particles that are emitted using a custom area controlled by procedural maps. Okay, so let's go back there, and we say that this one is essentially the color-based emission. Let's say that this one is colored in this way, and we can do something more, and I mean, we can use the possibility to paint the attributes over there. So let's say that we have the same subdivide. Let's go there just to have a better visualization. So that's our sphere. Then we say attribute paint. Okay, you see that there now we have a new attribute that is called mask. So let's say that this one is set to on. And if we like to paint, we have the left mouse button. By the way, we have to use the handle. In this way, you see that we are painting some area to control where we have the particles. Now it means that if we go there and we say scatter, and we say again to use the density, but this time we go to use mask, you see that we have the particles there. So let's see if we go to have an higher value. Let's set to the geometry as points, so it is more clear what we are doing. And it means that if we go back and we say let's paint something else, you see that it's adding points step by step, so that's really nice. And obviously over the attribute paint we can say, for example, erase, then we go to remove some areas, or if we like to have more little scale, we can go and make some more complex stuff, you see. So that's really interesting because we have the possibility to control manually with a painter what's going on, and that's really nice because we can paint directly over the surface, and that's really amazing. Okay, so back there you see that we have the points. Obviously we can use a lot of points, and you see that it's really high detailed. Let's go back there. This one can be used again as a pop network, so let's say that we use this color and also this one, so both. Ctrl C, and let's go there, Ctrl V, and we go to connect the new scatter there. So that's the new point, and that's the new particle system. So you see that we have the particles that are flying away from the new stuff we created there. Okay, let's say that this one is another group, and it is the attribute paint basin. And let's go with a new color. So we have different ways to control the emission. Ctrl S to save. There are more stuff we have to check about the emissions, so let's say that we use this one. And maybe that's right. Okay, we can use this one. So let's remove the guide and Ctrl S to be sure that we are saving. Let's go back to the bird. So we played a little bit with our constant activation, and the constant activation is going to use the birth rate. So we know that we have 5,000 particles, okay, by second. And to be sure about it, let's see the information about this one. We have at the beginning 209 points. Let's go to see when we have 1 second. We have 5,002 points, and that's just because it needs a little bit of love about the sampling for the emission. By the way, you see that it's working in the right way. So if we go at frame 44, we have 10,000 particles. Let's go back at the beginning. Let's say that we have no constant activation. See that we see nothing. Let's say that we have 500 particles. Let's go to say here we have 500. Let's go at 24. And we have 500 for every single frame. So in this case, obviously we have 24 frames, so we have 12,000 points. Okay, so that's by frame and that's by second. Now, just to have a complete idea about what's going on and how the particle works, let's say that we have a new, this one will be not used because it's old. We can remove it because it's from the other project. So let's go for a test geometry and let's try with Crag that is animated. That's really nice. Okay, so that's simple animation. You see that we have this creature moving. Let's go back in our plane. We like to see also the other stuff inside the scene, and this one can be removed. And we go to say that this one is now 25 meters, right? 25 meters. So we have this creature moving inside our scene. That's really nice and simple. So let's go inside Crack. Okay, let's see that we have a pop network. This one is connected directly there. And you see that we have some kind of problem about the visualization. And that's really simple. We can do some stuff. First of all, let's convert to poly this mesh. Okay, so sorry. This one now it's connected. Let's say that this one is named to poly. Problem is that you see we have particles shows as sprites, so it's really something really strange. To solve this problem we have to remove the material, because you see that there we have the material over this one, and if we go inside the attributes you see that there we have over the primitives we have the shop material path. So to do something like that we can use the attribute, let's go manually, attribute delete, we can remove it there, and let's say delete material, and it's over the primitive. You remember that there it was over the primitive. Let's go there and say remove this one. So you see we have no material, now we have the polygon, and now we have essentially again the emitter. So now it is working in the way we know. So you see that it is emitting particles. By the way, we can say let's go for a scatter and let's go for a point pop. So we go to emit particles flying away, sorry, not a point but a point pop. So that's connected. Okay, and select area emission. With this one we go back and say that we like to have the same configuration we had before. So we had the anti-alias noise, we had the point there, we have this one to make the color, and let's say that the frequency is higher, so we have small area, and let's say that we have an higher coloring just using this one. Okay, so if needed we can use later a fit. By the way, let's go for a vector to vector 4. So let's use this one as a frequency, and we use the time to control with this one. So sorry, that's my mistake. Okay, so now we should have the right one. Let's go to say that we have sorry, that's my fault, it's the position obviously. Let's go back there and let's say that the frequency is lower. There is something strange. Okay, also there I made some mistake during the connection, sorry. Let's say again that we have maybe 10, 10 and 10, and we have the amplitude set again to 24. Maybe 5, 5 and 5. Okay, so back there we have the scatter, and the scatter is made by density and it's using the color. So you see that the emission is always different. Okay, then we have there, let's go for using points. Let's remove the guide. So you see that we have this kind of emission, and then I think is that we say that the particles have a life of 5 with 1.5 about the possibility to be alive. And let's say that we have the gravity, okay, and let's go back there. And about the scattering, let's say that we have more points, okay, back inside there, and let's say that we are going to use all points. So you see we'll have a lot of particles. So this one obviously it's not so fast. By the way, let's wait. Let's say that we have let's go for a low amount at the beginning. So let's say maybe 100, and back inside we have the particle emission. We can use a pop color to color our particles. And let's say that those particles are maybe green. Okay, so the particles are emitted, they are falling down. That's really simple, but I like to have some kind of speed, so let's remove this one for a moment. And about the possibility, let's see if we have something like, you know, a wind. So let's go for a pop force. We are going to use this one as a force, so we say that the force is over the z-axis. So you see that we have this kind of wind, and then the particles will die obviously, so it will be nice. And let's go for a little bit of turbulence, so we'll have this kind of turbulence there, and back with the gravity. So now we have the gravity back, so if you see we have this one falling down. Just to make something more interesting, we can have a lower value there, so you see that it's falling down in this way. On the other side, let's say that this one is set to on, and inside the grid emission, let's say that we have an extrude volume. Okay, so we have a 3D mesh, and when you like to have collision, we can do something really simple. We can go there and say that we have a static collision. Okay, so it is done. If we go inside the pop network, let's press the L, and you see that we have something new. It created some little mistake there. We have a static solver for the collision, but this merge is wrong in this way, so let's solve the problem. This one needs to stay there, and then we have the gravity back there. Okay, so it needs to stay later. If we go to check, you see that the particles are falling away, they are bouncing, and then they will die. Okay, so let's go to see what's going on. we have the bouncing. Obviously we can control everything about the collision and the other stuff. By the way, let's say that we have just maybe 2 seconds with half seconds for the variance. So we have the particles falling down, and then they will die in a few. You see? Okay, that's done. Let's go back there. Let's say that we have gained points, and it is working. Obviously it will be nice to have a really huge amount of particles, so something like that, it will be nicer. Maybe we can go for 10,000, so it's a lot of particles. It will be a little bit slow, so it's something that can be essentially, let's go to save, so we can use a file cache, and maybe this one can stay later an output point. So we know that this is the particles, then this one is an output point, out particles, and if you like, let's say that this one using the Z key is set to the out, and then with the color we are going to use this one. So let's remove this one, sorry, let's remove this one, oh sorry, again, Control X, so that's our out point. Then we can have there a new node, let's call it geometry, and that's the particles. So over there we say to do a file cache. By the way, before we have an object merge, the object merge is going to pick the particles inside crack. So merge particles. By the way, you know, we have a problem. You see that we have also the plane, and that's because inside crack, over the top, we have the output there, and we have all objects. But we need just the particles, and the container is the pop object. So we have to go there and say, please export just the pop object. Back there in particle, let's say that we like to see just there. Cache this one. Let's leave the naming as we have there. Right mouse button there, delete. Let's try to see just 100 frames and say load from disk. Obviously we have an error because we didn't save. Let's save, and now you see that we have the export. So it's done. So if we go there, now it is saved. We have a lot of attributes that can be removed, so for the moment we are not talking about optimization. So you see that this one is really huge about things that are exported. By the way, if we like to have back the crack, we can use a new output, and let's say that this one is the out crack. But we need to change the output number. Sorry, this one is the output 1, so this one can be the output 0. Color, let's say that this one is green, and about the icon, again this one. Okay, let's remove the zoom. So this one is removed, and then we have a new geometry, and this one is you know, we have the object merge. Let's say merge crack geo, and then we go to pick the geometry. So inside crack, output crack. Okay, we have the geometry back. So then we have everything. So that's the emission, and this one is the crack for rendering. Okay, so now it is working perfectly. We have obviously no collision, we should work better with the sampling there. You see that the movement it's not the best one. By the way, it is something nice that can be useful to understand the basic of particle emission. So guys, that's all for this chapter. We have to start playing with something more complex, so we need to start working on a more complex setup and understanding more interesting feature, the forces and stuff like that. So let's move forward with the next chapter.